matrix of I is n cross n. Now I said rat can move only in two directions, only in this direction or only in that direction. Now rat wants, in fact, let's just say that, hey, rat wants to move in all four directions. Okay, let's just say that rat moves in all four directions. There are four possible directions rat can move into. I want you to tell me whether the rat can reach the exit or not, first thing. And the second, the bigger brother of this problem is, tell me how, if a rat can reach from the starting point to the ending point, how many different possible ways are there? In this case, I mean, if I just get rid of this particular one, a rat can reach the end goal either by going this way, or by going this way, or by going this way. Not this way, I think, or by going this way. Right? So there are three possible ways in which a rat can reach the exit. So there are three possible ways, right? One is this, one is this, and one is this. Okay, so there are three possible ways. Yes. So this is the first step is find whether a rat can reach, and second step is how many ways. Okay, सोचते हैं इस क्वेश्चन को कैसे कर सकते हैं. ठीक है, so I'm gonna create the same matrix again. ठीक है, और इस मैट्रिक्स के अंदर अपना rat यहाँ पे और अपना exit यहाँ पे. It's clear. So ठीक है, so this is how it looks like. चलो अब देखते हैं, जब भी मैं किसी पॉइंट पे होऊंगा, तो मैं चार डायरेक्शन में जा सकता हूँ, या तो मैं आगे जा सकता हूँ. Just listen to my explanations very carefully. Okay, so when I'm at a position xy, right, when I'm at a position xy, I can move in four directions. It can be x y plus 1, it can be x y minus 1, it can be x plus 1y, or it can be x minus 1y. Is that correct? So we have four options every time I'm there. Now, how will I decide which direction I can choose? You can choose any direction, right? I mean, as long as it's giving you a result, you can choose any direction. So let's say I decide to come here. I decide to come at this point. Now from this particular point, I can go back here. I can go up, I can go down, I can go left, I can go right. Should I go back? I mean, if I go back, my code will keep on rotating in this loop, right? My code keep on going like this, and I'll get TLE very soon, right? I'll get a TLE very soon. So should I do that? Answer is no. How will I keep track? So my problem is how will I keep track of the path which I've just come from? The first condition is do not visit the visited one. If it is already visited, I'm not going to visit it. Second, I have to make sure I stay in the matrix. अपन लोग matrix के अंदर रहेंगे. So these are the two conditions. And third condition is I have to make sure I'm not jumping on that X cross. Okay. So do not go on X. So we also not want to go to X. So these are the three safety conditions which I'm going to follow every single time. And while I do that, I keep on traversing till when? Till I reach the last point end, which is X minus final capital X minus 1 and capital Y minus 1, right? So this is capital X minus 1, capital Y minus 1. I'll start from here. I'll keep doing this thing again and again and again till I reach the last position, or till I'm out of options, till I have exhausted all the steps. Matrix problem looks like. This is how a matrix problem is thought. So the really beautiful thing about this rat in the maze kind of problem is that the code of these problems are really beautiful, and they look exactly the same for most of the cases, right? So you know what? Let me tell you how it looks like. I'm gonna remove this code just to remove the, just to bring more clarity. Chalo, let's get started. So you're given a matrix, okay? So you're given a matrix and you want to figure out whether you can reach at the endpoint or not. So I'm going to do a bool. Let's call it rat in maze. And inside that, you're given a vector of vector, a bool. Let's call it matrix or whatever, matrix grid, whatever you want to call it. Now, the number of rows is equals to mat.size, and if r is equals to 0, that means my matrix is empty, then means return false. That means not return false, let's just say return true. I can always reach any point because it's an empty matrix. Now you calculate C as well, which is mat 0.size, correct? So this gave me column value. So let's just say that all the points which are true are in fact, you know what, let's do one thing. I mean, it's going to take more amount of memory and I should not encourage that. So maybe let's keep it at 1. So I mean, it just becomes more easy. Okay. So if it is 1, that means I can go from it. And if it is 0, that means it's a blocker. Okay. That means it's a blocker. Chali. So this is row and column. I'm also going to create a visited matrix, correct? A visited matrix should have the same configuration as the original matrix. So what I'm going to do is I'm going to make it vector, bool, and okay, I'm going to define the capacity right now, and I'm going to make everything false. Okay, now it looks good. I just did a wrong thing. Okay, Chali. The reason I'm not doing in the original one, I mean, of course, it's gonna save me n cross and memory. That is a good solution, by the way. But sometimes you do not, you may not want to touch the original matrix, right? And I generally prefer not touching the original one. Yes, your answer is totally right. We can totally make this matrix as the one called visited, right? Where we can mark whether a particular element is visited or not by making it maybe 2 or 3 or something else, correct? You can do that. You can totally do that. Chalo. And from here, I'm going to call rat in maze. Return rat in maze, in fact. Return rat in maze. And in this rat in maze, I'm going to pass my maze or the matrix, my visited one, the position from where I'm starting, the position where I'm ending, correct? Sorry. I think this should do it. Chali. Now I'm gonna go write the helper function. Bool rat in maze. It has vector address mat, correct? It has vector bool visited. Of course, I'm going to pass it by reference. Not. Then it has the current position where I am. Then it has total rows, total column, right? These are the only things which I want. Now I'm in this function. What again? Both the condition. First is base condition, and then the recursion. Correct? That's what we discussed all the time. What is the base condition? The base condition is if x is equals to r minus 1 and y is equals to c minus 1, you know what? You got a solution, right? In that case, what I do is let's mark visited x and visited y as true and return true. Correct? Because we are through. We have reached there. So that is one thing. And one more thing. What if the edge case, right? What if I should control Z? What if this last stop itself has a capital X? What if the last stop itself is unreachable? Can I ever reach this X? Answer is no, right? So I'm going to probably do one thing. I'm going to probably Also check that this maze R minus 1, C minus 1, not maze, matrix. Okay, so this is what we want to do. So this is one condition which we want to check. Now I want to check, I mean, if the base condition is not reached, it's definitely possible that we have not reached the endpoint, right? We're not there yet. So what are we going to do? We are going to check कि ये जो current position हम जिसके ऊपर खड़े हैं, ये जो current position जिसके हम खड़े हैं, यहाँ पे खड़ा होना safe है या नहीं है? Correct? So let's check whether it is safe to stand on this position or not. अगर इस position पे खड़ा होना safe है, तो हम लोग वही काम करेंगे जो हम लोग हर बार करते हैं. क्या? हम लोग चारों डायरेक्शन में मूव करेंगे. करेक्ट? हम लोग चार डायरेक्शन में मूव करेंगे. तो चलो पहले काम करते हैं, पहले लिखते हैं कि हम लोग सेफ कैसे हैं. ठीक है, मैंने तुम्हें सेफ की 3 कंडीशंस बताई थी. क्या क्या कंडीशंस थी वो? विजिटेड नहीं होना चाहिए, मैट्रिक्स के अंदर रहने चाहिए, और डेफिनेटली एक्स के ऊपर तो नहीं होने चाहिए. ठीक है, तो क्या कंडीशंस है यहाँ पे लिख देते हैं. बोल इज सेफ, लेट्स कॉल इट इज सेफ. वेयर इज दैट? इज सेफ. अपन, और ये सारा का सारा मुझे चाहिए, तो यहां से मैं सीधा कॉपी कर लेता हूँ. So how will I check whether I'm, if, or या फिर simple return if x is greater than equals to 0 and y is greater than equals to 0. In fact, हम लिखते हैं x is less than r and y is greater than equals to 0 and then y is less than c. So ये चार conditions क्या these 4 conditions, what will they ensure? These conditions will ensure that I'm within the matrix. Okay, next we have to check whether it is not visited. Okay, and you have to make sure that it is not visited. So visited x comma y is also false. And final condition, you have to check what? You have to check that the current position is not an x. Mat x comma y is equals to 1. If it is 0, then that means I cannot go. So this condition will ensure that it's not an x. This condition will ensure that I have not visited this cell, and this condition will ensure that I am within the matrix. Right? So these are the conditions which I wanted. Correct? So let's just fill these values. Oh my bad, not. Let's see. Okay. अगर ये safe है, तो now it becomes more interesting to write the loop. So I'm gonna for I plus plus, correct? So I have to traverse in 4 directions, correct? I have to traverse in 4 directions. So if rat in maze mat visited, अभी x और y लिखते हैं थोड़ी देर में, और R and C. ठीक है? If this condition is holding, if I go to the next position and that next position gives me a true, what does that mean? If I go to the next cell and from that recursion I'm getting a positive value, this particular function call, which is the next function call, is giving me a true. In that case, what I know that I've gotten a result, so I return true as well. Correct? And if I don't get this value at all, if I don't come inside the slope, or even if I come, I don't get a value, I'm going to return a false. Correct? But I did not do one thing. What? If it is safe, let's visit it. Right? Let's mark it that, hey, I'm visiting it. So I'm going to mark it as true. Now that I have done that, I also have to do a backtrack. Right? Once your work is done, I told you, once your work is done, what you have to do? You have to backtrack. So I did the backtrack here. Okay. So now I can move in 4 directions, right? So I'm gonna create let's call it int. How to create a, I've forgotten about yes. int x moves. I always do that because it's quite interesting. So 0, 0, 1, minus 1. Okay. Int y moves is equals to 1, minus 1, 0, 0. Okay. My bad. Okay. These are the different combinations. So now I'm gonna write int next x is equals to x plus x moves I, and y is equals to int next y is equals to y plus y moves I, correct? So next x and next y. You could have written the 4 if statements, those would have worked as well, but I don't like that. I mean, this for loop looks really pretty, correct? So this actually looks really pretty, right? So actually one should do is hash define possible moves 4 and set the value 4 as possible moves. Now this looks more pretty. Okay, that's how you define a constant values. Okay, chaliye. So this is how your code is going to look like, my friends. Chaliye. If we are done with that, I'm gonna work on this one last question. अभी ग्रिड वाला एक और क्वेश्चन कराऊं या फिर एक नया क्वेश्चन कराऊं? ठीक है, ठीक है, एक काम करते हैं. अच्छा, एक चीज करते हैं. तो मैं एक क्वेश्चन की तुमको स्टेटमेंट बताऊंगा और उस क्वेश्चन को मैं सॉल्व नहीं कराऊंगा, बट उस क्वेश्चन को हम लोग कल जब आएंगे तो पहला या दूसरा क्वेश्चन वो कर लेंगे. ठीक है, तो क्वेश्चन ये है, इट्स एक्चुअली यूनिक पाथ 3. लीड कोड पे अगर तुम यूनिक पाथ 3 करके सर्च करोगे तो मिल जाएगा. ये कह रहे हैं कि आपको एक ग्रिड दी है. I'll just tell you this question and I'll not solve it. अपन लोग इसको कल सॉल्व करेंगे. In fact, let me show you यार, इधर दिख जाएगा तो और बढ़िया है. ठीक है जी. So यूनिक पाथ 3 में आपके पास कोई एक स्टार्टिंग पॉइंट है, आपको पता नहीं है वो कहाँ पे. आपके पास एक एंडिंग पॉइंट है, वो भी आपको पता नहीं है कहाँ पे. स्टार्टिंग पॉइंट को लेट्स से मैंने 1 से डिनोट कर दिया और एंडिंग पॉइंट को मैंने 2 से डिनोट कर दिया. ठीक है, और यहाँ पे ब्लॉक्स भी हैं इस तरह के, वो -1 से डिनोट होंगे. इफ देयर इज अ वॉल इट इज डिनोटेड बाय -1. रेस्ट द एम्प्टी ब्लॉक्स आर डिनोटेड बाय 0. गॉचा? ठीक है जी. तो माय पॉइंट इज I want to start from 1, I want to end at 2, and I want to make sure that I have covered all the 0 cells exactly 1. Okay, question is, I want to start at 1 से start करना है. I want to end at 2 से end करना है. And I want to make sure that I traverse all the 0 cell, these empty cell exactly 1. All the cell, so 2 conditions, traverse all the cell including 1 and 2, right? And you have to do it exactly once. All the cells exactly once. Is this question clear, guys? We have to find the total number of ways in which I can do that, in which I can start from 1, I can end with 2, traversing all the empty cells exactly 1, and making sure and finding the total number of paths through which I can do that. It's mandatory to visit all. Yes, it is mandatory to visit all the cells except the -1 वाला cell. -1 वाले cell को visit नहीं करना है. Okay, I think this is the confusion. -1 वाले cell को visit नहीं करना है. इन cells के ऊपर नहीं जाना है. 0 वाले cell के ऊपर जाना है, 1 वाले के ऊपर जाना है, 2 के पास जाना है. But एक ही बार जाना है. You cannot visit the cell 2 times. You cannot visit the cell 2 times. You start with 1, you end with 2. We traverse all the remaining cells. Yeah, this one does not have a solution. That's correct. I mean, you cannot. Yahan se, how will you go there? Yeah, you cannot. There is no solution for this one. वापस you do not have to come back. You start with 1, you end with 2. That's it. You do not have to come back. वैसे that can also be a solution, right? That can also be a question, that you start from one cell and you come back to that. No, you come back to that, but you traverse all the cells in the path exactly once. That can also be a question. I think there is this problem in graph called what do you call it? I totally forgot. It's called Eulerian Hamiltonian graph. Oh, the traveling salesman is also like that, but it is also optimization. This is a hard level problem. I mean, not hard per se. It's easy, but it's hard. So the fourth question, fifth question, whatever the question is, it's n queen. Okay, so I'm going to tell you about this n queen problem. There's an n queen problem and there is a word break problem as well. चलो ठीक है, word break मैं कल कराऊंगा. So there is this word break problem as well. I'll show it to you tomorrow. No problem. It requires some more amount of attentiveness, and by the end you guys get exhausted. No worries. Sudoku, yes, we can do Sudoku as well. Sudoku is same as n queen, so we'll see about that. Anyway, so this n queen problem is, so you are given an n cross n matrix. You are given an n cross n matrix. You know what I'll do? I'll just find a good image from internet. Okay. Chaliye, let's think about it. So n queen problem says, if you guys have played chess, or even if you have not, I'm just telling you. So there is a object called queen. Okay. Now queen can move in different directions. A queen can move either horizontally, or a queen can move vertically, or a queen can move diagonally. Okay, so queen can move like that. Apparently it's the strongest equipment on the chessboard. So queen can move in all these directions. Okay, so queen can move in all possible directions. So I'm at the chess point. So this is the queen. This is how a queen reacts. So on the chessboard of n by n, where n is equals to 4, what I'm going to do is I'm going to place 4 queens. I'm going to place 4 queens on this board. Okay. How can I place it? So there are 2 things. First is place n is equals to 4 queens on this board. Second condition, make sure no queen kills another queen. What does that mean? I mean, if a queen is placed here, then you cannot place another queen here, because this queen will attack it, right? This queen will attack it, and we do not want that. Another thing is, if I place the queen here, second queen here, this queen can again attack it. So basically, I cannot, if one queen is placed on this one, I cannot place a queen here, here, and here, correct? Because it will attack it. Similarly, if a queen is, let's say, placed here, this one, so I cannot place another queen in this line, in this line, and in this line, and in this line, correct? So I have to find out the position of positions, 4 positions, such that the queens cannot attack each other. Okay, so this, my friends, is a question. Let's think about the solution for this one. Okay, let's think about the solution for this one. Hey, I placed. Okay, so let's start. If I place a queen here, let's say I place a queen here. I be bold and place a queen here. Okay. Now I cannot place a queen in this row, right? This particular column, right? So I start with another column. So I have placed a queen in this particular. Now we are going to jump on the next column. Can I place a queen here somewhere? Can I place it here? No, it's not safe. Can I place it here? No, it's not safe. Can I place it here? Yes, absolutely. Now this one is safe because this queen and this queen cannot attack each other, correct? So this column is also filled. Let's jump to the next column. Can I place a queen here? No. 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 Correct. So I know that I cannot place a queen in this particular column anywhere, right? So that means I have to go back and I have to backtrack. Okay, I'm going back and I'm doing a backtrack. So I said that, hey, this position is not working out for me. Can I choose the next position? Yeah, okay, let's go to the next position. So next position is this one. Can I place the coin here? Queen here? Yes, I can, because still this queen and this queen are not killing each other, correct? So let's say I place the queen here. So then I start again in this loop. Now I say here, no. Can I place it here? Yes, I can, right? Because this queen and this queen are not cutting each other. I mean, they're not attacking each other. Can I place it here? I mean, of course, if this is done, I do not need to go any further. So I have found a position because this queen and this queen are not attacking each other, and same is the case with this particular queen and this particular queen, correct? So this work is done. So I jump to the next level. Can I place queen here? No. Here? No. Here? No. Here? Again, no. So I cannot find it here. So I backtrack. I figure out another position. Can I place the queen here? No. Here? No. Because this queen will kill. So that means this position of the queen is also not a good one. So I go back to the first row, first column, and I replace this position and I come here. Okay. So now I know I'm at this position, right? So I place the queen here. Now jump to the second one. No, no, no. Let's place it here, right? This is a safe one. Again, third one. Can I place it here? Yes, you can, because it's not, these two are not attacking each other and these two are also not attacking each other. So this is a nice position. Next, queen. No, no, yes, this one is it, right? So this queen cannot attack, this queen cannot attack, and this queen cannot attack. Hence, this is the optimal solution. चलो जी, तो अपने को बताना है. Oh shoot! If you type on my screen, it's going to be bad. Okay, don't do that. हाँ, चलो, तो अपने को रिटर्न क्या करना है कि हम लोग प्लेस कर सकते नहीं कर सकते. तो हम लोग वेक्टर रिटर्न करेंगे. Vector of bool and n queen. Okay, and we have an input n, the number of queens which I have to place. It's so let's create vector int, not int, my bad, bool chess. Let's call it chess, and the chess has size n. Vector bool n. Also, I created an n by n matrix and I placed everything as false. Okay. Now, what I'm going to do is, I'm going to again n queen. This time I'm going to pass this chess I'm going to pass a column number, let's say, which is 0. And do I need to pass anything else? No, let's think about that later. And I'm going to return this chess back. Okay. So void n queen vector bool address of chess. Okay, and we have int of n, correct? So if, oh my bad, shoot. So what I do is, let's do one thing. Let's pass n as well. I do not want to keep checking the value of n. So you have int x, not, let's call it n. Let's call it capital N. And I'm gonna make it constant int. If n, So many problems. If n is greater than or equals to capital N, that means my work is done, right? That means I've reached the end position. Let's make it capital equals to. Anyway, I'm not gonna. So what I'm gonna do is I'm gonna return. If so, I told you, right? There are a bunch of couple of things. So first is base condition, and second thing is recursion, correct? So if this is the base condition, right? If this is the base condition. I'm going to write the recursive condition here. So for int I is equals to 0, I is less than, I can move in all the bottom directions, right? So it's going to be n I plus plus. Now I have to check. I have to check whether if is safe. I'm going to again write the same function. Whether this particular position on the board, board of chess I, in fact, let's call it x. That will be much better. X, and I'm going to call it y. Okay. If is safe to move at this position x and y, if it is, what I'm going to do is I'm going to mark that as visited. So chess x comma y is equals to true, right? This is what I do, and I also do a backtracking here, correct? Chess x y is equals to false. Okay, this is the backtracking which I did, and inside that I passed n queen method one more time. The chess x is not required. I'll just need to pass y, that y plus 1, and n will remain the same. Okay. I think it's going to be not void, it's going to be bool. Because sometimes the case can arise when there is no solution. And if it is true, you return true. If it returns true, it may not necessarily mean that other position is true. It should. And I try return false here. And let's write the function and then think about that later. Okay. So bool, I'm going to write the is safe function. Okay. So is safe function will contain again the same kind of thing. Chess x y. I'm also going to pass n. Int x. Okay. So x y. Let's pass n as well. So I'm going to check for these conditions again. What are the conditions? The first condition is that I have to check whether the other queens are not cutting it or not. Okay. So first, let's go back and check whether a queen is cutting it at diagonal or not. For int I is equals to x, I is greater than or equals to 0. I'm going behind and I'm going to check whether this queen is cutting anything or not, right? The way we discussed. And if chess I comma y is true, that means a queen is there. That means this is not a safe condition. Similarly, I'm going to check now. Look at this particular part, buddies. So whenever I am at a position, let's say this particular position, let's say I'm at this particular position. So I'm going to check in 3 directions. I definitely know that ye wala condition, this particular column is safe. right? And I'm going to check for this column, this particular diagonal, and I'm going to check for this particular diagonal. Okay, so I'm going to check for whether it's on. Hey, somebody's on. Nitin, mute yourself. Okay, okay. So I'm going to check horizontally to the behind. I'm going to check diagonal up. I'm going to check diagonal down, just to make sure that no queen is cutting this particular one. Okay, chaliye. So now for int I equals x, y j equals y, I is greater than or equals to 0 and j is greater than or equals to 0. I'm going up first. Okay, and I minus minus and j minus minus. Okay, and if this condition is met, if this condition is true, you return false. Okay, similarly, I'm going to copy this code for the downward stream as well. J is equals to y, I is less than or equals to n, not equals to, I is less than n, then I plus plus. Now I'm going down. If this is true, then you return false. And once this part is done, what you do is you return true here. Okay. So first I'm going to check horizontally back. Then I'm going to check diagonally up. And then I'm going to check diagonally down. Correct? If this if say function is true, if this is say function is true, what's going to happen? I'm going to come inside, I'm going to mark that as true, and I'm going to check whether I'm getting a positive response from there or not. If I don't get a positive response, what am I going to do? I'm going to do a backtrack. So the first question was generate parentheses. Then we have keyboard, then we have permute, right? Then we have power set, third, fourth. Rat in the maze, unique path. We did unique path 2, not unique path 3. Unique path 3 is your homework. Okay, so unique path 3 is जिसके अंदर सारे zero traverse करना है. We did unique path 2, and we also did n queen. Okay, so these are the questions.